So if you weren't here last time, I'm recording the lectures because I have an online 151 and I have another non-lecture 151. And they said that the videos that come with the book aren't the best, so I am supplementing them. And I'll share it with you guys too, if you want to hear my funny jokes again or whatever. Actually, I can do this, make sure it's... Okay. All right. Now, how do we do this? So remember that, did you guys all get this? Maybe I should make this a pop quiz. Pop quiz. You guys doing it? So to show that the second one is a square root of I, all you got to do is square it, right? See if it equals I. So this first one, let's see, we go all the way back to, this is equal to I to the 51 power, right?
Yes, frozen.
Oh, still frozen. So we take 51, we divide by 4, and that's going to be 48. Remainder 3. So this is I to the third power, which is what is it?
-1.
Negative I, right? So you can think of it as I squared times I. I squared is -1. Or negative 1 times I, which is negative I. All right. Now this next one, let's do this one by hand. So we have the square root of 2 over 2 plus the square root of 2 over 2 I equals, oops, not equals, square it, square root of 2 over 2 plus square root of 2 over 2 I. I'll let you guys try that out. So FOIL is the trick. FOIL. Now remember what square root of 2 times square root of 2 is equal to what? Square root of 2 times square root of 2 is 2. Right? Now square root of 2 over 2, you're a step ahead of me. So we do the first one. Square root of 2 times square root of 2 is 2. 2 times 2 is 4. So it's going to be 1/2. The outer, that's going to be the same thing, 1/2 I. The inner is going to be 1/2 I. And the last is going to be 1/2 I squared. Now what is I squared? Negative 1/2, right? So this is going to cancel out this one. And we have I. So the square root of I, one of the square roots, is this weird number here. Who'd have ever thought, right? Any questions? Yep.
Can you go back to the first one?
Hmm.
So, how did you get 51 out of 12 or 3?
Well, you divide by 4.
Yeah, I got that.
So 12 times 4 is 48.
Okay.
So the remainder is 3. Would you agree?
Yeah.
Do you take the remainder? And that's all you care about.
Oh.
Because it repeats every 4. So, because it's on the bottom, negative, so then it goes on top. That's a good question because students will still miss these a lot on the test. They'll forget. I don't know what they do.
So why?
Negative I.
Okay, I'm
So why? How is the like how the second one is equal to I? How is it the square of
The second one?
I? Yeah.
Well, if I square this, so would you agree that this is equal to negative 2 over 2 plus square root of 2 over 2I squared?
Yeah.
Well, isn't this, we just worked it out, equal to I?
Oh, okay.
So therefore the square root of I equals. Yeah. Good questions, good questions. Question? Negative I. I cubed is negative I. Down here? Well, 1/2 I plus 1/2 I is 1 I. Why do we divide by 4? Were you here last time? Were you here last time? Yeah. So why do we divide by 4? What do your notes say? Look back in your notes. I could tell you the answer, but it's funner when you look for it. Why do we divide by 4?
Because it repeats every 4.
It repeats every 4, right?
So you always do it?
Do you guys remember this? So this is why I have a warm-up, because it's obvious that we might not remember this. Now I know who's done their homework for 3.1. So I is the square root of negative 1, right? So I1 is just I. I squared is negative 1 by definition. I cubed is I squared times I. Would you agree?
Yes.
And what is I squared? Negative 1. And that's what we just had, the problem we just had. I to the 4th is I squared times I squared, which is negative 1 times negative 1, which is 1. So the secret here is that once you get past this, you can always factor out a multiple of 4, right? Because this is just 1. You can just ignore it. So let's say we have I to the 9. I to the 9 is I to the 4th times I to the 4th times I. 1, 1, I. You see it? So every multiple of 4, it repeats itself. You guys remember that? So another good thing to do before class is, well, first of all, it's best to do your homework before class because then you're really ahead. And then are you guys printing out, or did I post those yet? No. But it's also good to review your notes before class. And then say, what did we do last time? Because we're going to start right away doing 3.2, right? So it's good to know what was 3.1 all about. Now, what was the significance of complex numbers? Why did we introduce them for? Well, to be fair, we met a week ago and there was a rodeo. And I know everyone in here is cowboys and cowgirls. So you guys were all at the rodeo. Or is that a bunch of bull? Why did we have complex numbers for? Why am I required to teach this? I mean, I could teach you anything. I could teach you about Jupiter right now, right? It's useful knowledge, I guess. I think it would be out of this world. So, why did we introduce complex numbers? Because you guys are allowed to look back in your notes. Or maybe I didn't explain it good enough, so I'll just do it again, I guess. But maybe I did, and then we can go on. Why did we have to have a complex number? Why do we have to have negative numbers? How do you solve, remember the problem I gave you? How do you solve that? You need what? You need, if you only have positive numbers, you cannot solve this. So this, back in the day, was an unsolvable problem. Before you had negative numbers, people would say, this doesn't make any sense. Like, what sense does it make? If I give you a $5 bill, you have $3 in your hand. Does that make any sense? Right? How is it that you can give someone $5 and in their hand it just magically turns into 3? That doesn't happen, right? So this is talking about something more abstract, like, all right, I got $5, but I owe my friend $2, so I really have $3. But you don't really have $3, you actually have $5, right? But see, you're doing this accounting in your head. It's abstractions, right? So to solve this stuff, you necessarily needed a square negative number. So what was the next problem that arose? And this one was pretty simple. We started out with -1, which we can solve, right? So this one was x equals plus or minus 1. Because it's x plus 1, x minus 1 equals 0. You can solve that. And then I said, well, let's just do this little plus 2 to it. This harmless adding 2 to this little problem. And what happens?
That's what happens.
This is like a Ouija board, right? It's like, what happens when you do this? And I am moving it around, like, right? I shall never ask this question again. So how do I solve this? I end up needing imaginary numbers. Not just imaginary numbers, but negative imaginary numbers. What the heck is that, right? It works though. It works. So now we're caught up on complex numbers. You guys remember my memorable lecture from last week that you all forgot? All right. It's the rodeo. I blame the rodeo. All right, 3.2. Quadratics. So has this been flickering lately? How'd you guys know it was going to go off? Because what? Because it's raining?
No, because of the sunlight.
Oh. Well, sometimes it starts blinking and stuff. Are you guys like, you know how like dogs can like sense an earthquake before it happens? Everyone's just like, the bulb is going to go out. Right? So. It's the opposite. Usually, like in cartoons, when you get an idea, the bulb goes off, right? Here, it like turned off, like fizzled away. All right, back to math. See, technology is really great. I can save this, I can forward it to you, you can send it to all your friends, put it on your Instagram, you know, and I could say, oh, you know what, I want to put something else here. But then what happens when the power goes out? What happens when the light bulb goes out? I can't do anything, right? Or at least with a chalkboard, you can, like, you know, use chalk or something. You can make chalk. And then what if you're writing on the sand? Right? You can always use a stick, do your math, and then you'll never run out of paper. Right? It's like the more advanced we get, the more dependent, and then when everything goes out, we're in trouble. I digress. All right. So this is a quadratic function. Now, let's think about this. We're upping the game here. This is now a second degree polynomial, right? Now, this is how I want you guys to think about this, okay? Think, whenever you categorize a problem, you're going to say, this is now a second degree. Now, is it going to be more complicated than a first degree? Yes. But how much harder? It's a second degree polynomial, and it has 3 parameters. So, for example, to draw a line, what do you need? A point and a slope, right? Right? You need 2 things. Now we need 3 things. So if I ever say, find this parabola, you need to find A, B, and C. 3 things. Okay? Now, sometimes we can be lucky and we only need 2 things. Now, wouldn't it be nicer to only find 2 things instead of 3 things? Because it's going to involve math, right? So that's one more math problem you have to solve. So there's this nice form called the standard form. I always grew up with it being called the vertex form, but we'll call it standard form, as the book does. Now, this is very powerful. This is when you start using the chapter 2 math in chapter 3. So this is saying the vertex is HK. Notice that it's the opposite. The H here is opposite. And A tells you the shape. It tells you if it's open up or down and how much it opens up or down. It could be like really skinny or it could be really flat. Now you just need 2 things. So here's an example to see why this is so important. All right, would you guys agree that this is a parabola that opens upward?
Yes.
And let's just suppose it looked like this. It may or may not. Well, we can always scale this so that it does. Now here's a question. Where does this go on the graph? Negative 16 what? But look, there's many ways to be negative 16. Right there. So let's say this was the point negative 16. That's the y-intercept, right? Well, that's the y-intercept at negative 16. This is the y-intercept at negative 16. In fact, this is the y-intercept at negative 16. Where's it going to go? Is it going to look like this? Like this? Like that? Like this? What's it going to look like?
Would you go over 4 and then down 16?
You can what? Go over 4?
Yes.
Why 4?
Because it's plus 4x.
No. Why not? So in this form, in and of itself, no one in this class can guess what it's going to look like, right? Or can somebody? Does somebody have these mad skills? It's possible. I mean, you could have just been flexing your muscles right now and then the power was flickered, right? Ugh. Light bulbs go out. That's why I don't flex in class. So what? How does it look like? Is there anyone in this class that can see how obvious this looks? What do you mean by 2? No, we're not doing standard form yet. Yeah, you got the right answer. You got the right answer, but I'm trying to show why you need standard form. Well, let's get to that point. This is obviously we don't know the answer, right? Except if you graph it or if you do standard form or something, right? So the question is, how do we know what it looks like? Now let's do standard form. So this is how you do it. Pay attention because it's very important. Hopefully I only have to do it once. Now what I mean by doing it once is you're allowed to stop me at any point. I mean, you're allowed to stop me anytime, okay? There's no rules. But don't wait till I'm done and say, oh, what did you do on step 1? All right? So stop me right away. Now, this is what we do. I'm going to color code this. Is that rain?
Yeah. It's literally so fast.
You never know over here because there's always jet planes. Right? You know what? Now, who wants to run to my car and roll up the window? Roll. See, back in my day, we had to roll up our window. Now it's like. Back in my day, we had to open the door when we were going to go into the drive-thru. I'll take a Big Mac, please, because your window don't go down. That's another example, right? If you don't have, if your car door if your window doesn't roll down, that never gets broken, right? But if you have a motor and the motor breaks, you can't roll down your window anymore. See how anyways. I digress again. Now, would you guys agree that, well, we'll ignore this last part for now. This part. Would you guys agree that this is equal? Stare at this and convince yourself that it's equal. Now, I might throw in some mistakes just to see if you're listening. Would you guys agree this equals this? Mm-hmm. Speak now or forever hold your peace.
You're missing the 2, right?
I'm not missing anything. If you multiply this out, you get exactly that, right? No? Multiply this out and see if you get this.
Well, you need a 2 there to get the 4.
2 times 2 is 4. The distributes?
Oh, okay.
Right. Oh, this is good. Stop me now. This looks kind of weird, but it'll make sense in a little bit.
Yeah.
Right?
I agree.
So you agree? But Adriana, you agree? Yeah. Question?
Aren't you supposed to subtract, well, obviously it's binary by 2, factors by 2, but aren't you supposed to subtract by 8?
No, this 16 comes from there.
Yeah.
I haven't done anything yet. All I did was rearrange it. That's all I've done so far. You guys agree?
Yeah.
Okay, now I'm going to do something with it. All right. Now what I'm going to do is I want to complete the square. Okay? I want this to be a nice perfect square. So what I'm going to do here is I take this number in front of the x Oops, I lied. You do half, and then you square it. Half squared.
One square.
Right. So what's half of 2? You can check on your calculator if you need to. 1. Now do this on your calculator. 1 times 1 is 1. 1. Now whatever goes there also goes over here. Now what have I done to this problem? I've added 2, right? And I subtracted 2. So is it still equal? Right? If I do, how much money do you have in your pocket? Here's $2, now give it back to me. You have the same amount, right? Why would I do this? Because I'm twisted like that. This is why you do this. That's a good question. Because this is like my girlfriend right here. And she's complicated, right? I don't know where she is on any position. I don't know if she's happy or sad or, if she's in a good mood today or a bad mood. Did you guys know where this probably is my girlfriend, I guess. So, did you guys know? Where? I don't know, right? I can't figure out. Because if she's over here, I'm in trouble. If she's over here, I'm good. Okay, these are all analogies, metaphors, right? So obviously the parabola is not mine. This parabola is not my girlfriend. Right?
So say if the function didn't have a coefficient.
It would just be 1.
You would just subtract 1 from
You mean
from the 16?
if this was just a 1?
Yeah.
You would just be, you would just subtract 1.
A 1.
Yeah.
Okay.
All right. Question?
Where'd you get the -2 on the outside?
Yeah.
Because if I'm adding 2, I have to then subtract 2. This 2, see, I color coded it. Purple and green. That 2 comes from this purple. That 1 comes from that one.
It has to be negative.
I'm saying, here's $2. Psych, give it back. Right? That's all I'm doing. Now, why am I doing this for? Because like I said, my girlfriend is complicated. I don't know if she's over here. I don't know if she's over here. You guys don't know either. Because she's crazy like that. I don't know the answer. So what I'm doing is I'm deconstructing her, right? I'm analyzing her. And I'm saying, well, if I think of her this way, because she's a, very complicated person. Then what I do is the following. I say this is 2, x, whatever number is right here goes right there. That's important. Remember that later. Now I have 16 minus 2 is what? Minus 18. Boom, I figured her out. She thought she could get away. I knew her smile was phony today. I'm not mad at you. I'm glad I met your girlfriend yesterday. Your ex. Anyways. Now is this informative? What's the vertex? Now I know where it goes, right? This goes like that. Or this is -1, -18.
I'm so confused on where you have the blue arrow.
All it means is you see this number 1, it goes right there. Why? Well, factor this. Factor this. Just try it on your own. You should be able to know how to factor this, right? This is a Math 92 question. Factor We should all know how to factor these by now, right? It's x plus 1, x plus 1, right? Well, x plus 1 times x plus 1 is x plus 1 squared, right? But what I'm telling you is you don't even have to do that. You don't have to do this on the side. You automatically have it right there. The reason that's important is because pretty soon we're going to have some crazy stuff right here.
But it's always gonna be the number that you get.
It's going to be whatever that number is. It's magic.
The half number?
Yep. This number right here is always goes right there. Sometimes you're going to wake up in a bad mood. You're going to see some nasty stuff right here. And you're going to say, I got you figured out. Here's some chocolates. So you're happy.
Why is it negative?
Why is it negative 1? What's the formula, standard form?
A times x minus h squared plus k.
Minus h, right? That's a good question. That's a silly mistake that we'll make. We don't want to do that. You could. Sometimes. Not always. Go back. Okay. So a good question was asked right now. Couldn't we just use the vertex formula? Yes. You guys know the vertex formula?
Yes.
No, what's the k going to be?
P of negative 2.
So let's think about this. This is a really good question. It's actually where I was going next. You guys are reading my mind here. So, and there's another way to find this. We could, I'm just going to sit right here. We could, so how would you use the vertex formula?
It's negative b over 2a.
Negative b over 2a, okay. So this is a different way to do it. So actually, it's the axis of symmetry. The axis of symmetry is x equals negative b over 2a. Okay. Now the reason the axis of symmetry is important is because when you have a parabola, the vertex is on the symmetry. So imagine that was symmetric. This is the axis of symmetry. This is like your belly button, right? Your belly button, well, it's not really your belly button, but and the axis is right there. So obviously, h is negative b over 2a. Would you guys agree with that? Because if this is h, k, and I also know that this is true, then h has to be negative b over 2a. So I could have got that right away. 4, in this case, it would have been 4 over negative 2 times 2 is negative 1. Now the question is, what is k?
You plug it into the formula.
You got to plug it into the formula. Now sometimes this is easier, sometimes it's not. Negative 2x plus 4, blah, blah, blah. Let me remember that. So now I got to do p of h, which is p of negative 1 is, I already forgot it, 2 negative 1 squared
Plus 4.
Now what if these are big numbers? What if this is 3 radical 42 times 256 squared? You know, Which way is easier? I don't know. Maybe this way is easier. Sometimes. Sometimes it's not. So what is this going to be? 2 times 1. In this case, it's pretty easy. -1 times -1. Be careful. -4. And this is -18. So guess what? We found this another way. This is K. So now you have 2 different ways of doing this. We just doubled the amount of knowledge you had. Either way works. Some students prefer this way. Now look at the calculations we did here. I did +1 -2. That was the hardest calculation I did. What's the hardest calculation I did here? Well, these can get complicated if they're big numbers. But here was, I'll let you guys decide. I report, you decide. Question.
Well, I guess I can get the same answer, but I didn't do it that way. I factored out the 2, divided P of x by 2, and ended up multiplying everything by 2.
So you divided by 2,
Yeah, divided everything.
and then
by
you
2,
multiplied by 2.
And then it was a longer step, obviously.
No, that's the way some teachers will teach us. They'll divide by 2, and then they put it back at the end.
Yeah.
But in the end, it's the same process. So sometimes this 2 is complicated, right? So sometimes the books will do, let me do it that way. It doesn't hurt to show you all the ways to do this. A third way. Like, who are you calling way? All right, so the third way is to say, well, I am going to just get rid of this -2 because it's complicated, or this 2. So I'm going to write P of x divided by 2, and then I'm just going to have x squared plus 2x minus 8. Now I can do the same thing. What's nice here is I don't have to factor anything out. So then I just write x plus 2x plus something minus 8 minus something. So now I don't have a number in front. So here what I'm saying is add something, subtract something, you break even, right? Now what is that something? 1 squared, 1, 1. The magic still applies here. Now what am I missing? This is actually wrong. What am I missing? Well, ignoring that part, what am I missing? X squared. Yeah, that's kind of important, right? So this becomes x plus, here's the magic. You see it? Right there. Squared minus 9 is equal to P of x over 2. Now what is P of x equal to? How do I solve for P of x? Multiply everything by 9, right? Now you guys got 3 ways of solving problems. Not just 1, not just 2, but call now in the next 15 minutes. I'll throw in a 3rd solution to this problem. You guys know how those scams work? When they say, like, let's say you're going to buy like a ShamWow or something amazing like that, and it's like $19.99, and then the shipping is like $6 or sometimes $13 or something, right? And then they say, if you call now, we're going to throw in another one. What they don't tell you is that they charge you the shipping on the second one, right? And so then you end up paying like $34 when you thought it was $20. Well, wait, there's more. So, yeah, there's more costs. You guys got this? You guys are pros? All right. So, this one. Which part? Bottom part? See, that's a jet, right? So we either live in the most safest place in the world or the most dangerous place in the world. Because the Tucson area we got the Army intelligence at Fort Huachuca. We have an Air Force base. Phoenix has an Air Force base. And then pretty soon we're gonna have a wall. And we're gonna be so safe. I mean, no one will ever jump over it. But we're either the safest or the least safe, because if you wanted to really attack America, you would attack Tucson first. And Raytheon, because all the Patriot missiles. You know Patriot missiles are like $2.4 million each. Every missile they build is like an elementary school, and they buy thousands and thousands of them every year. So I'm just telling this story while you copy this down. I'm your narrator. So, now this one I'm going to ask you to do it by the first method I showed you, because we're going to need that for our next step. So convert to Catholicism. Standard form. Let's get the evil out of this math problem. Like I said, do it the first way, because we're going to need that for the next problem. We're about to do some kung fu in a little bit.